All right, 7.9.3 is about areas and perimeters of composite figures. So a couple things we need to talk about. First of all is the definition of a composite figure. So a composite figure is a figure made up of more than one shape. So it's sort of one big shape that's made of two or more other shapes put together. So here's a couple examples. You can see the blue shape. You can be decomposed or broken down into two smaller shapes, a square and a triangle. And then the orange shape can be broken down into two smaller shapes, a rectangle and a semicircle. So what we'll be doing in this chapter is finding, or in this section, is finding both the area, so the sort of 2D space that this whole shape takes up, right? The flat space that the shape takes up the area, and the perimeter. So that's the distance around the outside of the whole shape. Okay, perimeter is the distance around the outside, the whole shape, and then the area is the 2D space that the shape takes up. All right, so then a few things to remember vocabulary and formula-wise. The perimeter, like we just said, is the distance around the outside of a figure. So think about it like putting up a fence. And how much fence would you need to surround that figure? So basically going only around the outside is the perimeter, the distance around the outside. And then the area is all the part inside of the figure. So how much space that figure takes up if it was laying flat on the ground. Okay, the area of a rectangle or a square or a parallelogram, we find that by taking the base and multiplying it by the height. So area of any sort of rectangular figure, the space that it takes up, is base times height. The area of a triangle is the base times the height divided by 2. Okay, and in a triangle, the base and the height always have to meet at a right angle. So if you're looking for the height of a triangle, it's always the part that meets the base at a right angle. And for a triangle, we take the base times the height and divide it by 2 to find the area. To find the perimeter of a triangle or of any other figure, really, we just add the lengths of the sides. So whatever those different sides are, to find the perimeter, you add the lengths of the sides. Okay, area of a circle, as we talked about yesterday, is pi times the radius squared. And circumference of a circle, so the distance around the outside, is pi times the diameter. All right, so this is what it's going to be asking you to do on most of these, is find both the perimeter and the area of a figure. So let's start with this one. You can see that this compound figure, or composite figure, what does it call it? Composite figure, is made up of a triangle, right? And a semicircle. First, we're asked to find the perimeter. So we're thinking about a fence, right? Going around the outside. How much fence, how long would that fence have to be to go around the outside? Well, we know it would be 8 plus 6, right? If we go down this way and then over this way, that's 8 plus 6. And then we have to figure out what this distance is around the circle. Well, we know that that's a semicircle, so it's going to be half of the circumference because we're just talking about the outside. So we'll do the circumference, which is pi times the diameter, or 10, and we'll divide that by 2 because it's half of the circle's circumference. So then we just do our addition. So we get 14 plus pi times 10, so 3.14 times 10 is 31.4. Divided by 2 is 15.7. And then we add those two together and we get that the total perimeter of this figure is 29.7 feet. All right, so then with area, we are no longer talking about the outside of the figure. Rather, we're figuring out how much space this composite figure takes up. So we need to find the area of this triangle and add it to the area of this semicircle, right? So we're going to take the area of the triangle, And we find area of a triangle by doing base times height over 2. That's our triangle. And we're going to add it to the area of that semicircle. Okay, and to find the semicircle, we would find area of the circle and divide it by 2. All right, so let's take what we know about the triangle. Base times height is 8 times 6, and we divide that by 2 to get a triangle. And then if I erase this a little bit so that we can see the dimensions here. In order to find the area of the semicircle, we need to find the radius of the circle. So if the diameter is 10, we know that the radius is 5 feet. And then we can plug that into our area formula. Pi is 3.14 times 5 squared. So by radius squared. And then we divide that by 2 in order to get half of a circle. All right, 8 times 6 is 48, divided by 2 is 24. Oh my gosh, this is not working. 24 plus 3.14 times 5 times 5 is 25. So 3.14 times 25 is 78.5, divided by 2 is 39.25. And then our last step is to add these together. So the area is equal to 63.25. When we're talking about area, we always put our units squared because we're talking about 2 dimensions in area. Okay. All right, next one. Here's another figure. Same thing, it asks us to find both the perimeter and the area of the circle, or not of the circle, of the composite figure. Now, think about the perimeter. We're only talking about the distance around the outside of the shape. So we've got all of these little semicircles, right? We basically have 4 semicircles that we need to just add up the distance, the circumference of these semicircles. So if we find one semicircle, let's say we find this, we're not doing that part. Let's say we just find this part of the semicircle, one semicircle. Right? To find that, we would take pi times diameter and divide it by 2. That would give us one of those semicircle circumferences. Then there are 4 of those, so if we find that and multiply it by 4, we would figure out this entire distance because you have 4 outsides of a circle here. So let's try that. Pi times the diameter, and so the diameter of each of these circles here, we see it out here, is 2. So pi times 2, and we'll divide that by 2 in order to get a half a semicircle. When we do this, those 2 just cancel. We end up with pi, and we need 4 of those, so times 4. So 3.14 times 4 gives us 12.56 inches for our perimeter. Then let's look at the area. Okay, the area is no longer just going around the outside. Now we have to figure out how much space this whole thing is taking up. So again, we've got 1, 2, 3, 4 semicircles. So 4 of the semicircles, that's a semicircle, plus 1 square. And if we add all those up, that'll give us the total area that this shape takes up. So let's start with the semicircle. Find one semicircle. We know that the semicircle will be the area, pi r squared, divided by 2, divided in half to give us half a circle, and there are 4 of those. If we look at each of these little semicircles, we know that the diameter is 2, so the radius of this circle is 1. Now we can plug that in. Pi times 1 squared, and we'll divide that by 2 to get a half. I'm going to keep going down this way. 4 times pi times 1 squared. 1 squared is 1 times 1, or 1, times 3.14 is 3.14. And then we divide that by 2, and we get 1.57. Multiply that by 4. And the total area of all of our semicircles is 6.25. We will add that to the area of our square in the center. And so we know that the base and the height of our square is both 2. So we're going to do 2 times 2, which is 4. So we're going to add 6.25 plus 4, which gives us 10.25 inches squared. And that's for the area that this figure takes up. All right, last one, little word problem. So here we have a basketball court where it tells us that the center of the court, that you can see it's a little blue circle there, the center of the court has a radius of 3 feet. So this has a radius of 3 feet. Okay, that little blue circle, it's painted blue. The rest of the court outside of that blue circle is going to be stained brown. They also tell us that 1 gallon of stain covers 150 square feet. How much stain will you need to cover everywhere but the center? So let's think about this. We're given the dimensions of this court. We know that the court has dimensions of 50 by 80. So let's start by finding the area of this entire court. 50 times 84, base times height. So 50 times 84 is 4,200. So we're looking to stain, to paint this whole thing brown. But we're going to only paint everything except for that blue circle. So we need to subtract the area of that blue circle. So the area of that circle would be pi times 3 squared, right? Or pi times 3 is 9, which is 3.14 times, 3.14 times 9, 28.26. And because we're not going to paint that blue circle, we'll subtract that amount from our 4,200. Which leaves us with 4,171.74 square feet. That's how much needs to be painted with the blue circle removed. Now, that's not what they asked us. What they asked was 1 gallon of stain covers 150 square feet. How much stain will you need? Well, if 1 gallon covers 150 square feet and we have 4,174.74, we need to take this 4,171.74 and divide it by 150. Divided by 150, that'll tell us how many gallons of stain we need. Okay, when we do that, we get 27.8116 gallons. However, you don't buy paint in little tiny decimal increments. You buy it in whole gallons. So what would make sense here is to round up and say to the next nearest gallon, you would need 28 gallons of paint to cover the non-circle area of this basketball court.